Hello everyone, my name is Sirisha Gatpa. I'm currently a graduate student in data science at UMBC. Today, I'm excited to present my capstone project titled Predictive Analytics for Detecting Fraud Transactions in Credit Card Data. This project is a part of my academic work showcasing the application of predictive analytics to detect fraud transactions. So let's explore how this predictive analytics contribute to combating fraud effectively. Coming to the introduction, the purpose of this project is to enhance fraud detection mechanisms to prevent financial losses and protect the users. The objective is to predict and visualize the fraud transactions using a Streamlit application. And for this project, the scope includes detecting the fraud while offering insights through data visualization. So let's dive into how predictive analytics plays a crucial role in enhancing fraud detection and prevention. This slide outlines the key research questions driving the project. Firstly, can machine learning models accurately classify the fraud transactions? Secondly, which features significantly predict the fraud? Thirdly, how do geographic locations impact the likelihood of the fraud? And lastly, what patterns emerge from analyzing the fraud across categories, job, and states? So, addressing these questions helps uncover actionable insights for the fraud detection. Coming to the details of the dataset, I have taken the dataset from the Kaggle source comprising over 5,55,000 rows and 23 columns over the size of 143.64 MB, spanning various times, locations, and transaction categories. So, this extensive data allows for comprehensive analysis of transaction patterns, aiding in development of robust fraud detection models. Also, in this dataset, out of 23 columns, I have identified the key columns that will help in detecting the fraud transactions. The fraud variable here serves as a target variable, while all other columns will act as a potential features for the analysis. In the methodology, it begins with the data preparation, which involves gathering the data sets and gaining insights into its structure and pre-processing it. So key steps include performing EDA and data visualization to extract meaningful insights. For data modeling, the SMOTI technique will be employed to address class imbalance. Multiple machine learning models will then be trained and evaluated. Finally, the best performing model will be deployed in a Streamlit application, enabling the predictions, visual insights, and interactive exploration of data visualizations. So, coming to the EDA, I have conducted EDA and it revealed the patterns like the higher fraud in shopping and the personal care categories, certain professions with elevated risk and specific time frames with increased fraud activity such as late nights. So the visualizations helped me distinguish patterns between fraud and non-fraud, informing the feature selection for the modeling. As I mentioned earlier, to address data imbalance, we are using the SMOOT technique. This is necessary because, as seen in the pie chart, 99.6% of transactions are non fraud, while only 0.38% are the fraud. So, the SMOTI technique helps to balance the dataset by generating the synthetic samples for the minority class, ensuring the better performance during the model training. So, in the first step of the EDA, I examined the distribution of transactions across the category field. To analyze this, I plotted two graphs for both non fraud and the fraud. So, for the non fraud, the top three categories are gas transport, grocery POS, and the home, with gas transport being the most prominent. Whereas for the fraud, the leading categories are gas POS, grocery POS, shopping net, and malicious net. Interestingly, grocery POS appears in both fraud and non fraud, suggesting it deserves closer attention for the further analysis. Coming to the next one, this is the top 10 transaction amount across the various job fields. Based on the analysis, certain professions such as a commissioning editor, licensed conveyancer, and occupational therapist exhibit the higher percentages of fraud transactions, whereas color technologists show relatively low fraud rates, which could be attributed to lower transaction activity in these fields. And this graph is a detailed visualization of transaction activity throughout the 24-hour day period. So between 12 a.m. to 11 a.m. for the non-fraud transactions, the activity remains relatively stable. However, from 11 a.m. to midnight, there is a noticeable increase, indicating the higher activity during this period and people are more active. Whereas for the fraud transactions occur late at night from 10 p.m. to midnight or early in the morning 12 a.m. to 4 a.m. So this suggests that the individuals with malicious intent are more likely to exploit times when human monitoring is reduced. So, coming to the next graph, it's a detailed transaction activity across the days of week. So, both charts exhibit a similar pattern with Sunday and Monday, and also Tuesday recording the highest number of transactions for both cases. This suggests that the transactions occur on these days may warrant closer scrutiny as they are more likely to involve fraud activity. So this graph is the transactions across the states. So if you see the states with the high non-fraud transaction counts are Texas, New York, Pennsylvania, with Texas leading significantly, and other states also have the substantial transaction volumes. Whereas for the fraud, the highest number of transactions occurs in New York, followed by Pennsylvania and Texas. States like California and Illinois and also Virginia show notable levels of fraud activity, but the numbers are much smaller compared to leading states. So this graph helps state field could play an essential role in identifying the patterns of fraud activity, as certain states appear to have significantly higher fraud compared to others. Coming to the modeling for data balancing, we have used the SMOTI, which is nothing but synthetic minority oversampling technique to address the class imbalance by generating the synthetic samples for the minority class, ensuring the model is not biased towards the non-fraud cases. And we have divided the dataset into training and test with a ratio of 80:20 and evaluated multiple models. And also we have taken the best performed model which has effectively handling the feature importance and capturing the non-linear relationships. And for the model deployment, we have trained the random forest model for the deployment in the Streamlit application as it performed well. For the modeling performance and prediction, it addressed the class imbalance using SMOTI and tested the various algorithms with random forest emerging as a best model. It achieved an impressive accuracy of 99.6%, as it is more because of the class imbalance, and also the balanced precision recall and F1 scores of 1. The strong performance ensures effective fraud detection while minimizing the false positives and negatives. Also, the confusion matrix highlights the model as predictive power, no false positives, minimal false negatives, and the strong balance between true positives and true negatives. By setting a decision threshold at zero point 0.5, the model captures the majority of fraud cases while maintaining the higher precision. Coming to the Streamlit application design, so it provides an intuitive interface for the fraud detection and data visualization. Users can interactively explore patterns and receive predictions in real time. So this interface enhances the usability, making it easier to interpret and act on the model outputs. And also, uh, this is how it looks for prediction upon giving the data. And also for the visualization, this is the interface design, helps users to detect fraud and visualize the patterns effectively. So the first graph is highlights the fraud rates across the transaction categories. So key insights include a gross POS as the highest fraud rate among all categories, and other significant categories includes malicious net and shopping net. And also the other graph, fraud percentage by job. This displays jobs such as commissioning editor, licensed conveyancer, and therapist occupational shows higher fraud rates, and roles like color technologists have low fraud rates. So these visualizations provides an intuitive way to identify the higher risk categories and professions, aiding in the refinement of fraud detection strategies. And these are also few more graphs which is across the time. uh, Here, if we see the peak time between 10 p.m. and the midnight, the lower fraud activity is observed during the most of the day, particularly between 5 a.m. and 9 p.m. And coming to day of the week graph, it activity is highest on Wednesday, followed by Tuesday, and also fraud is relatively low on Saturday and Sunday, indicating the weekends are less prone to fraud activity. And this is a map visualization graph which shows the fraud hotspots with states like Texas having the high fraud count. So fraud is concentrated in specific regions with denser clusters in eastern and southern states. So these insights can guide targeted fraud detection strategies based on time, day, and location. Coming to the future scope, looking ahead, we aim to integrate real-time prediction systems for instant fraud detection. Continuous monitoring and the modeling recalibration will ensure adaptability to evolving fraud patterns, enhancing both accuracy and responsiveness to new threats. And these are the limitations. If we see, models rely highly heavily on the quality and the completeness of the data set. Any missing data can significantly impact the accuracy of fraud, and use of the SMOTI for addressing class imbalances, while effective, but may introduce the synthetic patterns that do not fully represent real world scenarios. So model performance depends heavily on the provided features. Any changes in transaction data structure or introduction of new features would require retraining and revalidation of the models. And also, random forest, though highly accurate, can make interpreting results more complex due to their ensemble nature, potentially reducing the transparency in decision making. And in conclusion, I developed a model significantly aids in detecting and managing the fraud risk for financial institutions by leveraging the features like transaction categories, job roles, and geographic data. So the model promotes proactive fraud prevention. So for the future advancements, including the real-time systems, will further bolster its effectiveness, supporting the trust in digital financial services. Let's explore the Streamlit application. So this is the view. Upon giving the fields, it would detect whether the data is fraud or non-fraud. So if you click on the predict, we can able to see the given data is predicted to be fraud. And also for the visualizations, I have provided the two fields, category and the state field with all its values. Right now I'm selecting all, and if you click on the visualize data, we can get the graphs as I mentioned earlier. So for the more details, you can visit my GitHub profile. Thank you.